sample is a representative section of the population, a smaller part of the population taken for testing. So obviously, if we are going to use a sample to talk about the population, that sample should correctly represent the characteristics of the population. So population, of course, therefore, is the larger group that we have to think about or we target. So let's see how we select a sample. I will look at the two main branches of sampling techniques. We have probability samples and non-probability samples. So when we say probability samples, you can see we have these four types. One is the random sampling, or we say simple random sampling. And the other one, then we have stratified sampling and the cluster sampling. So what do you mean by simple random sampling or random sampling? Well, you have to have a listing of the population and generate random numbers to select a sample from the population. So in that case, let's say we have the complete list of students at our university, AEU. So we want to select a sample of students for our testing. So we define, let's say, our target population to be limited to those who are studying at our institute. So let's say we want to choose say we have our listed or registered number of students as say 200, let's say, but we want to select only say 25 of them. So how do we use simple random sampling to select this population or select this sample of say the 25 students? Okay, so let's see now how we can do it. I will open up an Excel sheet to show you how the random numbers are generated, and then I will show you how you can say find the selection. Okay, so here you can see an Excel sheet. Can you see the Excel sheet? Can you?
No, miss.
No, not the Excel sheet. It is in the file opening screen.
Not open yet, miss.
Now can you see?
Yes.
Right, okay. Now I have this Excel sheet, and I said in our say institute, we have, say for example, assume 200 students are there, and we are going to pick say 25 students for our testing. So how do we select these 25 students? First task we have to have is we have to develop a list of that 200 students. So student against each number. So student number 1 is who is so and so, 2 is so and so. Likewise, we have to have the list of the 200. Then say like this, you can go to Excel equal rand, then rand between, and I will say 1, 200, and then I can generate random numbers like this. So you can see that we have to select student number 40, 55, 116, 102, and likewise. So we have no interference in this selection. It's a completely unbiased selection. So this is how you select a simple random sampling. Now you understand why I said that most of the students are wrong when they say that they have used a simple random sampling, when we can very well see that they can't even think of developing a sample frame to select that sample, right? Then you can see the next one as stratified random sample. Of course, when you have a stratified sample, you actually the requirement of a stratified sample comes when you find your population is say having clearly identifiable uh, uh, segments within the population. Say, for example, I will take the same example of our institute. Let's say I want to find, say, what the students have to say comment about, say, sanitary facilities. So I would like to select a group of students from each, say, those who are following different courses. So I will therefore first thing say identify who are the different say students in the different following different courses. So say for example, if this is my population, say I find that 50% of the students follow say the MBA course, right? Then there is, let's say, another 30% of students following CMA and another 20% of students following another course, let's say. Now, we find that in our population here, the split is such that we find 100 students here, we find 60 here and 40 there, okay, in terms of numbers. Let's say I am selecting 25 students for my test. So first thing I have to do is I have to see how do I split this 25 in such a way that they represent these different groups in the population. So say for example, say 50% of this 25 comes to 12 and a half. Let's say I round it off to 13 students there. And then 60% of the sample 25 comes to how much? So say about say 40% of the 25 comes to 4, right? So the other I can put here, right? Say how much? So you split the numbers like that and you put them into each category, right? So here we have so 15. So this is 12 and a half. So that's there. So this is 30%, right? And this is 20%. I'm so sorry. So the 30% of the 25 students come to 7.5. So I will put it as, let's say, 8, right? So 13 plus 8 comes to 21. So the remaining 4 students I will assign to other groups, right? So now I have the split of the 25, where 50% of them are selected from one group, which are the MBA students. The other 50% split such a way that 30% of them are CMA students, and the remaining 20% say the students coming from the other courses. So here in terms of students it's 60, right? In terms of students it's 40. So 100, 60, 40 comes to the 200. But in terms of percentages, this is 30% and 20%. So 30% of our sample 25 is what I calculated here as 8, and then 20% of that is that's what I calculated. It comes to 5, but when I rounded off with the rest, I put 4 here. So now how do I select these 13 students? I have to develop a separate list for the MBA students, a separate list for the CMA students, and a separate list for the other students. So then within separately from those lists, I have to use the simple random sampling, right? Simple random sampling, and select each of these numbers to be within my sample. So that is how we have the sample of 25 chosen under stratified sampling. So when do we require a stratified sampling? We want a stratified sample when we find our population has clearly identifiable segments. Okay. The next type of sample you find is cluster sample. So this is where you find that your population has certain small groups. So rather than choosing individuals, what we do is we choose small groups. So let's say in our example, say I want the students chosen this way, right? I take each course and then I ask, okay, I'm not bothered about your say which course you follow, but rather within each course I will say include not the students, but get a list of students who have got together to do their assignments. Okay. So let's say I have 100 students who are following say MBA, which means I find that in every group there are students who have got together into groups of 5 to do their assignment. So I take the listing of that. So here once again I'm not taking the list of students, but I'm taking the list of groups. Right, so let's say I have these groups like this, say 1, 2, 3, 4. I have for the 200 students, right? When I divide 200 by 5, I should be having 40 such groups. Now, my selection is going to be out of these 40, where I use simple random sampling to so in your case, you can assume I'm going to generate random numbers between 1 and 40, and then I will choose, let's say, 5 groups. So let's say I select group number 2, group number 27, group number 31, and let's say group number 18. Okay. So now in each group, let's say I have 5 students. I take all these students. So I have to have one more group. Let's say I take group number 9. So now I have in each group 5 students. So all together here, I will get my 25 students. So here the difference is, you can see that we are not selecting students, but we are selecting the groups. And once we select each group, we have to take account of everybody who is within that group. Now let's look at our next method of sampling. The next method is systematic sampling, where we find the population here. In our case, let's say I have like this, right, up to 200 students altogether, irrespective of what course they follow. So within this 200, if I'm going to select 25, I will take the 200, divide it by 25. My answer is 8. So what I do is I have like this. I take the first 8 students and then randomly choose one out of the 8. For example, I choose student number 4. Okay. So now I have selected the student number 4. Then plus 8, I have 12. Plus 8, I have 20. Then 28. Like this, I select the students. So my sample will be now these students that I have chosen. So here one can argue that this is not purely random because only the first selection is random. However, well, not really also, because you find that there is a random selection as well. So you can see that these sampling methods, when we do our research, say for example as a survey, it is very difficult for us to practice these probability sampling methods strictly. But then you will ask, okay, why did you teach them? Because very many students say in their dissertations that they have practiced simple random sampling, which is wrong. So you understand it is not practically possible in most of the circumstances. Okay. So let's see now what do we have as the sampling methods which are not say probability sampling methods. Okay, so here we find we give our say importance not to be perfectly unbiased, but we sometimes follow practice methods where we can choose the sample based on convenience, or we might think that we have to choose individuals based on judgment because we value their expertise in the knowledge, or we think that they are knowledgeable people. So because of that, we might think that, okay, person A is more knowledgeable than B, so we will select that person. Likewise, we practice the judgment. We follow the judgment to select sample units. The next method is where we have something called quota sampling. So this is a method again where we identify certain stratification and we follow different method than simple random sampling to pick that identified number. And there is another method called snowball sampling. So that's what we are going to talk about in today's lesson. So basically, when you say convenience sample, all we have to do is we have to say select, we tend to select rather our sample based on convenience. So how do you practice it in your research? Well, if you send your questionnaire to everybody who are there within your within a network that you are connected with, so that means you're practicing convenience. So if you tend to give it to people whom you know and get their assistance to distribute it to people whom they know, of course, that is also your in a way you're trying to get it with convenience, but it can be described in another way, which I'm going to discuss as snowball sampling also. Now, here what happens is, well, when you look at the practical viewpoint, it's very easy to do. However, we have to be careful that when we do it this way, sometimes let's say I give it to my friends and they give to their friends. So it could only reflect a certain part of a population of similar thinking and different parts of the population may not be included if you follow this method. So because we are not trying to be completely unbiased, uh, so we give prominence to say other criteria like convenience. So purposive sampling or judgment sampling, as I said, is mostly practiced sometimes when you conduct qualitative research also. So I can then say I select an individual whom I think is an expert in the industry or expert in the field who has knowledge about the subject that I want to discuss about. So there, my selection is based on judgment, right? So, well, we have to be careful to identify the correct person rather than just selecting haphazardly, where then in that case we may not get the correct information from the population. Quota sampling is much similar to the stratified sampling that I discussed. Let's say your population has a stratification like this. Now, you want to select a sample where you decide, okay, your population is such that I'm going to select, let's say, 60 people from here, 50 people from here, and then another, say, 40 people from here, let's say. Now, what happens is you find that you know the numbers, but you don't know the listings to practice the correct method of stratified sampling. So once you know the numbers, then you practice a method like convenience sampling till you meet the sample size. So when you say if your target within say each group is met, you stop there. That's how the quota sampling works. Okay. Uh, so then you find that in qualitative research, as I said earlier, the methods like judgment sampling, because we focus on the characteristics or the knowledge of the person who is being interviewed in our case, right? So therefore, we look at the purpose and we look at the suitability of the person in our selection. Now, there is another sampling method, right? I won't go into all these details because for your knowledge, if you say purposive sampling, that's enough. But if you read this method called snowball sampling is very popular because it works well within qualitative research as well as in say quantitative research also. At one point, if you remember, when I was describing, let's say snowball sampling, under convenience sampling, I said that okay, you give it to your friends and then you give it to their friends, and what happens is there you pick one network and then you pick other networks connected with that network. Okay, why we call it snowball is because you find that when you throw a snowball, the ball grows. Okay, so because more and more snow gets connected to it, the ball grows. So therefore, you find that the snowball sampling also is somewhat like that, because you start off with one network and then you extend it to other networks. So you can hear this method almost every day, because when you listen to news, what they say is they say find people who are suspected to have COVID-19, then they look at what networks they are connected with, and then what those networks are connected with the other networks, and then they go into first round, second round, third round, like that. so that there is a large group of people connected. So that's the way we work with the snowball sampling. So coming back to your research, what kind of sampling methods do we practice? So in, I mean, 99.9% of the cases, when you're doing a survey, simple random sampling is not possible. So you may have convenience sampling, you may have judgmental sampling, you may have snowball sampling, or you may have quota sampling. These are the most, practical sampling techniques that we find. Okay, so that's actually what I have to talk about the sampling methods, right? This I have given for your knowledge. These are specific variations of the qualitative sampling methods. So with that, I will stop my discussion about the sampling method. Now I will share another slide or another document actually about the sample size. Okay, a lot of students ask me, okay, how much is my sample size? Okay, so let's see how you select your sample size, right? So some students ask, okay, is it enough if I select, say, about 150 people, right? So what I have to say is that for you to say it's enough, you have to justify that it is enough, okay, right? So let's see how we can justify that our sample size is enough, okay? So there is a table which is called Morgan table, right? You can even type this in the internet, right? So when you look at this table, you find that the table specifies the sample size to be taken, to be decided, for us to decide the sample size. Now I'm going to show you that table. So
Madam, we can't show.
yeah, just I'm opening that. Give me a second. Can you see a screen with a highlighted lines?
Yes.
Right. This is what is called this Morgan table. You can see here. You can see we use those same line of thinking using the confidence intervals to estimate a sample size. So you can see the table here. Now you are having this Uma Sekaran's book in hand to refer. If I remember correctly, page number 268 of that book carries this table. Okay. So how do you refer the table? You can see if the population is small, you have to take almost the entire population. Example, if your population is 10, you have to take the entire 10 for the sample. You can't leave anybody out. If it is 85, you have to take 70. If it is 460, you have to take 210. Right? If it is 7,000, it's 364. If it is 100,000, right, or say a million rather, for a million it is 384. So if you are doing a study like a consumer behavior related study, what's going to be your sample size? Of course, we can't exactly have a finite measure about the size of the population, but roughly, if you can estimate that it is more than a million, right? Well, we have to settle with 384. So what I tell the students is go ahead or plan to collect 400, so that even if you have to throw away a few, you still get 384. So if you look at a graph, right, how it looks like is, when the sample size is, when the population size is small, you see the, sample size is coming close to the size of the population. But you see, if it is reaching this, even more, the increase in sample size is less. Okay, so that's why I said we plan to have 400. Then we can to a greater extent assume that that is sufficient for us to talk about the population. Now comes the obvious question. Let's say if you're not able to collect data from 384, what are you going to do? Are you going to say that I have collected from 200 people and my sample size is 200? Is that your answer? In that case, if you have practical difficulties in meeting your number required, that is 384, what you can do is say that the actual requirement is 384. However, due to practical difficulties, it has been cut down to 250 since you could not say collect the whole number due to certain difficulties. So say that, but don't say the sample size is 250. Right? Because that shows that you're not aware about the actual required number, right? So I have now discussed about the sampling technique and the sample size. So when you're describing your sampling technique, you can, if you want to say that you're practicing convenience sampling, if you're doing a say correlational type of a study, or else you can say you're having a judgment sampling, specifically if you're doing something like a say qualitative study, right? And describe your sample size. However, when you're doing qualitative studies, this way of say sampling, sometimes specifically having a number becomes difficult. So because your population is small, so let's say ideally we do qualitative studies in situations when the population is small. So here you can see if the population is 30, we still have to have 28. However, when you are doing qualitative studies, even conducting 28 interviews is a difficult task. So therefore, in that kind of circumstances, we can still justify that, okay, we have taken 10 respondents, but they still represent all say aspects or all specific segments of the population. So we think that's enough, right? So like that, you can justify your number in the sample when you're doing a qualitative study. So that's what we have to talk about with respect to the sampling technique and the sample method. We're now going to move to our next topic, that's about how to test the reliability and validity of our data. Okay, so first of all, what do you actually understand by reliability and validity? Okay, both together you call them goodness, right? So then what we're going to talk about now is goodness of the measures, right? How we measure goodness is through reliability and validity. Can you see the screen with goodness of measures?
Yes, miss.
Okay. Now this diagram you find in your textbook where you can see goodness splits into two parts, reliability and validity. What do you mean by reliability? you look at it in two ways, stability and consistency. So stability again splits into two parts as test reset and parallel form reliability. So here what we do is say over a period of time, does this questionnaire produce consistent results? In your case, obviously, you will argue with me. How can you test that? Because we are going to give the questionnaire or distribute the questionnaire once and collect the data once because we want to finish our MBA. Obviously, we can't test it. So we don't go into test the stability aspect. Rather, we test the consistency aspect. So here again, when we test consistency, we use the method called inter-item consistency reliability, which is measured using a statistical measure called alpha, right? This alpha is more specifically described as Cronbach's alpha, right? So I will teach you how to find Cronbach's alpha when we explain the methods to test reliability using SPSS, right? So now you know our goodness of data is measured through these two aspects, and reliability is measured through inter-item consistency reliability. This is the method we use. Now let's look at the logical validity. Okay. So here we can also call it the say content validity, or we call it face validity. What do you actually mean by content validity? Say, when you develop your operationalization of a variable, do you include all required indicators of a particular variable so that you measure the variable completely? We'll take a simple example. I want to test the factors that affect the retention of employees. And one factor I found as rewards. So I want to test how rewards affect the retention of employees. So I'll put it across very simply. I want to test how rewards affect employee retention. How do I measure rewards? Okay, how do I measure rewards? I have to have adequate number of indicators. I will ask a question like this. You know, my first indicator is to find whether the rewards is based on performance evaluations. The rewards is based on educational qualifications. The rewards is based on experience. The rewards is based on industry salary levels, right? The rewards is based on, say, how, say, you present yourself, your presentation skills, right? Other skills and abilities, right? So now you see your rewards is decided based on a lot of things, okay? A lot of things. If you're making a questionnaire to measure the perception about rewards, then you should have questions like this. My employer, say, rewards the employees based on performance evaluation. Second question, my employer rewards employees considering their educational qualifications, right? Third question, experience is a criteria considered in deciding rewards in my organization. Then likewise, you have the questions and you express your answers from strongly disagree to strongly agree, where you have the answers quantified from 1 to 5. Now, you see, if I ask two questions about rewards, let's say I ask only these two questions and I forget to ask these questions. I don't ask these. I ask only whether the rewards is based on performance evaluations and the educational qualifications. I don't ask the rest. Now, I am not measuring the rewards completely. So my content validity is not there, right? Okay. So likewise, when you measure employee retention, also have adequate questions. You can say that I have no intention to leave this organization in the near future, right? I feel I'm bonded to this organization because of the attractive rewards, right? I have planned my career within this organization and have no intention of leaving, right? So likewise, you test the employee retention also with adequate indicators covering the full, say, variable. So if you ask a couple of questions, leaving out the most important variables, or rather the indicators, then you're not having the uh, uh, the content validity of the variable that you are measuring. Now, you find it's also being called face validity because when you look at it, you find on the face of it, it's talking about rewards, right? If I was talking about, let's say, say work-life balance, and talking about say occupational stress, when I am actually expected to talk about rewards, then on the face of it, it talks completely out of the topic questions. So therefore, we don't find the face validity, right? And obviously not the content validity either. So the next type of validity, you can see criterion related validity, which actually falls into two types called predictive validity and concurrent validity. So predictive validity is where you use one measure which is available right at the moment to predict something in the future, or something that has happened in the past to predict the future. Concurrent is you're looking at two things that are connected with each other at the same time. So I have this very simple example. I can use assignment marks of students to predict the performance at the exam. Now that's a predictive validity because assignment marks come before the exam. In that case, it becomes a predictive. So the assignment marks become a good predictor, right? And it has predictive validity. Now, concurrent validity is where, let's say, you find that two exam papers are held at the same time, and let's say I find that okay, the marks are having say, when I look at the students, those who have scored in one paper have scored better in the other paper, so they all happen to be there at the same time, not at two different times. So this is how we find, say, indicators which can be predictors, which can be concurrent related, say, indicators. Now, I have come to the next part of the validity, that is here. You can see the last box that comes here, this one, I have said construct validity or congruent validity, which falls into two types as convergent validity and discriminant validity. When you say congruent or construct validity, that aspect of validity, we require the support of SPSS or any other software which is capable of conducting advanced statistical tests to measure this aspect of validity. So it falls into two types called convergent validity and discriminant validity. So when you look at goodness of data, you find that say for you to measure reliability, you need SPSS because you have to calculate something called Cronbach's. For you to measure the logical validity and the criterion related validity, you don't need the support of SPSS. Why? As long as you have a good operationalization developed with adequate indicators which are good predictors of the variable, well, good representatives of the variable, then you find these aspects of validity is okay. However, that shows that operationalization is a very important part where you have to pay a lot of attention to it. Okay. So to pay a lot of attention to operationalization because the initial part of validity is ensured with the operationalization of the variables. So here again, to test the congruent validity or the construct validity, which has two parts as convergent and discriminant validity, we need the support of SPSS. So before we think about how to use SPSS, let's see how we define our congruent validity and the convergent validity and the discriminant validity, which are the two types of construct or the congruent validity. Now, convergent validity is a form where you find that the indicators that are there to represent a variable have strong connections with each other. Whereas discriminant validity is a situation where you find one group should be different from another group. Now let's look at it in a simple way. Let's say for an event we invite 5 families. Okay, we invite 5 families for an event. Say each family has 4 or 5 members in the family. So altogether, let's say we have 20 to 25 participants in our gathering. Although we have say 20 or say 25 participants in our gathering, they come from 5 different groups. Okay. So we find that when you look at a group which is a family, the members of that family know each other very well. But one family knows another family to a little extent, obviously not as much as they know about their own family. Okay, right? So if I put it across in an example, you see, it's something like this. I have a conceptual framework with the 5 variables like this. Okay. This is my dependent variable. I have a 5 indicators here. So here, 6 here, Now, I may be having altogether indicators about say 25, but they are not 25 different things having absolutely no connection with anybody else. No. Why? Because these four relates to one main concept, right, which is shown here. Whereas these four relates to this concept that is here. So what we expect is that these five indicators have close connections with each other. They are strongly correlated with each other. Whereas these four again are strongly correlated with each other. But these four are not strongly correlated with these five because they don't know each other, right? So now I will show you it with a simple example. Look at this. In this example, I have chosen two main concepts, right? One is self-esteem. The other one is locus of control, to what extent you can control your, say, you think you have control among within yourself, right? Now see, I have two variables where I'm going to represent each variable with three different questions. So you have three questions for self-esteem and three questions for locus of control. You can see here, say for the 6 questions, we have made a correlation matrix to find how each of the 6 questions are related with one another. You can see a series of ones down the diagonal. That's simply because the correlation with itself is always 1. So SE1 has a perfect correlation with SE1 because it's with itself. However, SE1 has a correlation of 0.83 with SE2. You can also say that SE2 has a correlation of 0.83 with SE1. It's like correlation between A and B is equal to correlation between B and A. So you find that your correlation matrix, if you carefully look at, you find that what is above the diagonal is same to what you find below the diagonal, right? So again, when you see, you find that the correlations between or among the three questions that come under self-esteem are, say, all strong correlations, which you see highlighted in green. Okay, that's what you find here. This is the correlations that you find the self-esteem questions have among themselves. Now you see in red again, this is the set of questions which come under locus of control, and you find how each one is correlated with one another, right? And you very clearly see that the numbers in yellow are very weak correlations and also they are or they represent the correlations that are there among the locus of control questions and the self-esteem questions. So it's like, say, you're trying to see how each member in one family knows about each member in another family, right? So that's why they don't know much. So they're not correlated, right? So what happens in convergent validity is very simply, you try to see how strong is this bond among the members in one family is. So that is measured through a certain set of statistical measures. And what you find under discriminant validity is where you try to see to what extent are those families knowing about each other. So basically speaking, we know that within a family the members know each other, but one family knows another family only to a little extent, obviously not as much as they know about their family. So if we have in our research, say, several questions like what I showed here, right? Like what I showed in my example conceptual framework where you saw. So maybe altogether I have several questions like this. These are my questions, or rather they are indicators, and I will be soon converting them into questions. So I may be having altogether, let's say, 25 questions, but of course they are not entirely unrelated 25 questions. They can nicely be put into 5 groups, okay? And the results that we find statistically should support these 5 groups, where we should find the correlations that this group has among themselves is much stronger than the relationships this group has with the next group. So that's how you test your convergent validity and discriminant validity. So don't worry, I will be teaching you how to use SPSS to test it. So this is an example of convergent validity, right? So how do you measure it? Self-worth, confidence, social skills, self-appraisal, all these things are there. Then you say you have a high self-esteem, right? And then say when you take that concept, it has to be different from another concept. So that's why we found earlier that self-esteem is different from the locus of control, which is a different concept. So putting everything together, what do you mean by reliability and validity? Reliability is where you produce consistent results and stable results. So it's like, say, hitting a target. If you hit the target correct, you find that your all your bullets or all your hits will focus on the correct target. That's just like what you see in the middle, where everything is focused around the center, which is the target. But if you find something like this, then what happens? Yeah, that is also a situation where all the bullets target on one target point. So it's all right. No, it's not all right, because you find that here it's not targeted to the point we want to target. Okay, so we find that say it's reliable, but it's not valid, because it's not talking about what we want to talk about. For example, my question is about rewards. So as I said, for me to correctly measure the perception about rewards, I should ideally be asking these people, okay, are you say being say rewarded based on your educational qualifications, you're rewarded based on your performance evaluation, and so on and so forth. But instead, let's say you find some really unrelated variable like, say, work-life balance, right? So you ask questions, okay, say, I don't have time for myself. I don't have time to pay for family related commitments. And let's say I have no time to relax, right? Quite often I neglect my commitments towards the family because of no time. Now, what are you talking? You're talking about work life balance. But when you carefully look at, yeah, all these questions are actually talking about work-life balance, and therefore I have reliability. However, all the reliability is there, it's not valid. Why? Because we want to talk about the rewards. We are not ready to talk about employees' work-life balance. So if you're going to talk about work-life balance instead of rewards, then well, it may be reliable because all of them are talking about work-life balance. Obviously, it's not valid because it's not talking about what I want them to talk about, which is rewards. Okay. Now, what you see on the leftmost, you can see is neither reliable nor valid. Why? Because none of those questions, okay, you can see one question actually targeting on the point, but others are all lower. So, well, you have made a questionnaire where you're looking at, say, how you're being rewarded. So there is one question saying that my employer rewards me based on the performance evaluations. However, the next question is about work-life balance, where you ask a question like, say, very often I stay after office hours and therefore tend to neglect the family-related commitments, right? And then the next question is about occupational stress. You can say that, say, uh, uh, because of the heavy workload, I always feel tired and have physical health problems related to stress, right? So now you're trying to talk about rewards, but if you're asking one question about occupational stress and another question about work-life balance and yet another question about, say, whether you're having career growth in the company, it's neither reliable nor valid, right? Both. So this is how I can explain you. You can measure the reliability and validity of the data. Okay. Are you having SPSS with you, students?
Yes, miss.
All of you,
Yes.
right? Okay, so I will show it on the screen, but you can of course, because while I am doing, I don't know whether you can also do it on the screen. If so, you can try and see. I will slowly explain and do it and explain you what is reliability and what is validity with an example. Maybe you can look at the recording and practice yours. So my next part of the lecture is where I will take a practical example of a data set to explain you what is reliability and what is validity. Okay. Do you want a break? Because I will continue the example for about Yeah, easily 1.5 hours. Do you want a short break?
Yes, miss. We'll have.
Yeah. We take a 15 minutes break to have a cup of tea and come.
Okay, miss.
Okay.